Hi, it's a guy Olumide, and today we are gonna be solving another one of the most commonly asked DSA questions in top tech companies, including Google and Amazon and Meta and Netflix and Apple and Microsoft and other top tech companies. So, the title of the problem is largest container. The problem statement says we are given an array of numbers, and this array represents the height of a vertical line on a graph. Each element in the array represents the height of a vertical line on a graph, and a container can be formed with any pair of these lines along with the x-axis. We are now asked to return the amount of water that the largest container can hold. This is a logical question that require a logical understanding of the problem statement and requirement. So let's consider an example. This is the example given. So for in solving DSA questions, you'll be given the problem statement as well as an example. So this example now, we see we are given an height and an output value. So this height, what they are trying to say in this problem statement here is that we are given an array of number. So, and we can see, if we observe, we can see that the element of the array, I mean 2, 7, 8, 3, 7, 6, the element of the array corresponds to a vertical line on the graph. Look at this graph now. You see that the element 2, which is the first element of the array height, corresponds to this line on the graph, while the element 7 corresponds to this height, the element 8 corresponds to this height, and that's how it goes. So each element in the array corresponds to a line on the graph. And we can also observe that the length of the line, or the length of each line, depend on the value of the element. Now the first element have a value of 2, and so the length of the first line is 2. The second have a length, a value of 7, so its length is 7, and the third has a value of 8, so its length is 8. Now let's consider two vertical heights. Let's consider two vertical heights, height 0 and height 1. These two heights. See the shaded portion, so represents the amount of water that can be contained between these two, between this container. So actually, each line corresponds to a line, a vertical line. But now let's have this illustration that each line represents the wall of a container. Okay, we have a container, and each of these line here, all represents walls of a container. So container can have two walls at the extreme, left and right. So let's consider this container now that is shaded, that is colored and shaded. So we realize that the total amount of water, or maximum amount of water that can be contained inside this, or that this container can contain, you understand, is actually given by this region that we shaded. Because if we try to pour more water into it, because the wall of this first one does not extend and is not long enough to the wall of this second one, it will be limited to it. You understand? When we keep pouring water above this particular region that we shade, it will just keep pouring out. Why? Because the length of the first wall is not as long as the length of the second wall. So the total amount of water that can fit inside this container is limited to this lesser height, or is limited to the height of the laser line. So, and that is why we have this formula: minimum of height of I minus height of j. So let's, in this case, our I is 0, which is the first word, the first line, and our j is 1. So the minimum between these two lines is what we are going to pick as the amount of water that's going to size into this container. Why? Because beyond or above this length, above this length, we see that the water will pour out. So it has to be the minimum wall, or the minimum line between the two between the two wall, or between the two lines that we are dealing with. So we see that the first line have a height of 2, you see, just like it is in this array. So while the second line have a height of 7, which is just the same as here, you understand? So the minimum between it is what we pick, and then we multiply it by the width. Though we know we are dealing with amount of water, we are dealing with the area, so the width will be given by 1 minus 0, you know, considering this place. So and that's what make up the amount of water that this container will contain. So we see that the amount of water is 2, because the minimum height is 2. Between 2 and 7, the minimum height is 2, and the width is 1. So the amount of water is 2. One thing we can notice from the graph is that if the extreme lines are long enough, we don't need to worry about the middle line. Okay, now this is what I'm trying to talk about. Let's say we pick our two extreme not to be 0 and 1 like we did earlier, but we pick it to be 1 and 4 as the walls of the container. We see that the amount of water will be up to this. It will be very tall, unlike when it is one that is just short, because the heights are tall and equal. So we see that the amount of water is not limited by the line that are within it. Look at these two and look at this 3. You understand? This index 2 and index 3. Now we see that it does not limit the line of the water. Why? Because the extreme are further apart from them, so they will not stop it. So the only condition, or the only way whereby it's gonna stop it, is when the wall is at this 3 or is at this 2. But once it is further away from it, it will enclose it and it will not stop it. So that's one observation that you put at the back of your mind. And another observation is that we might not know the longest height really, because that's what they are asking us to find, that we should find the largest amount of water that the container can contain. Or we know that but one thing we know is that the widest width exists at the extremes. What I'm trying to say here is that we know that, okay, to find the maximum amount of water that will be contained, we require the height, at least the minimum height between the two walls, and then we require the width, which is given by j minus 1. And what it simply means is that, okay, now that we choose our wall to be here and our container to be here, we are going to be doing something like 4 minus 1, because this is what constitutes the width of the container, and the width is important as much as the height when we are finding the area of the container, or the amount of water that the container can contain. So we might not know the height, you know, the array might change, they might give us another test input, but one thing we know definitely is that at the two extremes we have the largest width, you understand, which will be given in this case by 5 minus 0. That's the largest width we can have. So if we decide to take the container with the largest width, we'll be going for index 0 and index 5. So that's one we know for sure. By these two observations, we are gonna start our by these two observations, we are going to start by setting a pointer at the two extremes, because that one will give us a higher probability that, okay, we are going to reach a more larger container. Why? Because we don't know the height, we don't know how the height varies with respect to each other, but we know that at the two extremes we are going to have the largest width, and because the width also constitutes to the amount of water, we are going to go for the highest width that is possible, and that highest width is possible at the extremes. So we are going to be having 2 pointers now, and setting 2 pointers, one at the extreme left and one at the extreme right, so as to signify the wall of the container. So you see that the 2-pointer technique can also be applied in solving this problem. Why? Because to find the amount of water that a container can contain, we really need to know the width of the container, because container will have walls at the at the extremes. So, and by getting to know these walls and getting to know the minimum height, we can find it. And 2-pointer is good at doing something like that. So that's what we're going to be doing. So we are going to be placing and setting 2-pointer at the two extremes. We are going to be gradually moving this pointer inward, so with the hope that we might come across a larger container that will contain more water. So you understand. So it's fine if we place the extreme, if we place the left and the right pointer at these two extremes now, and we calculate the amount of water that we can get at these two extremes. But the question does not ask us to just return the amount of water. It says we should return the maximum. So we said return what amount of water that the largest container can hold. So we really need to navigate through the possible or all possible containers, so that we can know which one have the largest and which one can hold the largest water. So after putting our pointers at the extremes, we are going to be moving them inward, trying to check out if we can find a container that will hold more water. Now we started by placing the left and the right pointer at the two extremes, and we can see in the graph, so we can see that this is the area or the amount of water that can be contained in this container that we created by placing the left and right pointer at the two extremes. So now let's calculate the amount of water now. So right here, the amount of water is given by that same formula. You understand? Note that we are not going to go for this largest line at the right. Why? Because going for it will just cause waste of water. Why? Because when the water gets above this, above the left line, which is shorter than the right line, it will start to pour away. So the total amount of water or the total height of the container will be based on the minimum, and that's why we are using this minimum here to find the minimum between the left height of the left line and height of the right line. And height of the left line is 2, just like we can see in the array here, and just like we can see in the graph representation. And the height of the right line is 6. So the minimum between them, we will go for the 2. We are going to be multiplying it by the width, so which is 5 minus 0. So you see that gives us 10. So the amount of water that can be stored in this particular container that is created by placing the left and the right pointer at the two extremes is 10. Right now our maximum water is 10. Don't forget, the problem statement does not ask us just to find the amount of water. It really wants us to find the maximum amount of water. Although currently this is our first trial and the amount of water we have for now is 10, but probably we might later find out a more larger container that can hold more water. So we will just be saving the maximum water for now to be 10, but later if we come across a more larger water, we will update our maximum water to be that higher one. So now if we observe, we will realize that the left line is smaller than the right line. And don't forget that our aim is to get a container that will contain more water. So now progressing, the question is, which one do we move? Is it the left pointer? Are we moving the left pointer, or are we moving the right pointer? Now, because our aim is to get a larger water, we are going to be moving the left pointer toward the right. Why? Because the left pointer is smaller than the right pointer, and moving it toward the right, we might be fortunate enough to come across a larger pointer or a larger line. So because the goal is really to get a larger container, so we'll be moving our left pointer to the right, so that why? Because the left pointer is referencing a smaller line and the right pointer is referencing a larger line. So we have to move the left pointer to the right so that it could reference a more larger line and give us a more probability of finding a larger container. Similarly, now we have moved our left pointer to the right. It was previously at index 0, now it is at index 1, and now we see that graphically this is the amount of water that could be contained. Now let's evaluate it really. So we see that the left pointer is pointing at 1. Now we see that the left pointer point at a line that have height of 7, while the right pointer point at a line with height of 6. So finding the minimum between this line, we are going for 6 because 6 is the minimum. And now the width will be 5 minus 1. That's the width of this particular container, and multiplying it gives us 24. We see that the previous value we have is 10 and the value we have now is 24. 24 is greater than 10, so we update our maximum water to be 24. That is, we found a container that can bear 24 water, or 24 amount of water. So now the question is, which one do we move again, left or the right pointer? We see the left pointer is pointing at a larger line or a longer line of 7, while the right pointer is pointing at a lesser line of 6. So we are going to be moving the right pointer this time to the left. Why? Because that will boost our probability of achieving a more higher container or more bigger container. You understand? So if we move our left pointer to the right, it's like we are stooping low. We have to move our right pointer so that because the left pointer is greater than it, and if there's a better choice to make, is moving the right pointer to the left. At this point, we moved our right pointer from the last index 5 to index 4 now. So, and right here, let's calculate the amount of water as well. So, well, will I say fortunately, both the left pointer and the right pointer actually have the same height. The line are the same, which is 7, and therefore the amount of water will be 7 times 4 minus 1, which is the width, gives us 3, and that gives us an amount of 21. But don't forget that the previous maximum water we have is 24, so it's still greater than this current one. So we are not going to change it to 21 because 24 is still greater than it. We will stick to 24 because that's what the question asks us to find, the largest amount of water. So what do we do now? Which one do we move, left or right? You see, at this point, left and right actually have the same height. So which one do we choose to move? Well, regardless of which one we are moving, the next container is guaranteed to store less water than the current one. So meaning that the next container is guaranteed to store less water than 21. And why? Let's understand why. The reason is because, one, moving either left or right pointer is gonna reduce the width of the container. So if we move the left pointer or the right pointer from where they are, is either we are moving the left to the right, to 2 here, or we are moving the right to the left to 3 here, is definitely going to reduce the width of the container, and that means a reduction in the width here. So that's one. Another one is that even if we move the line to a higher height, we are going to be choosing the smaller or minimum height between the left and right height, meaning that, okay, fine, let's say we move this left now from position 1 to position 2, and now position 1 is at 8. You understand? But even it doesn't really have any effect. Why? Because we are still going to be going for this 7 here. You understand? Because 7 is the one that have the minimum height, and the minimum height is what we used to choose. We always choose. So the width is reducing, and even at the best case, the height will remain the same. That is if the one that it moves to is greater than or equals to it. So we see that anyway, anyhow, is always going to be less than the current water. So because of that, we are going to be moving our left to the right, and at the same time moving our right to the left. Why? Because if we move either of them, it won't make any sense. It will just be lesser than the current value. So to be more efficient, we are going to be moving both left to the right and right to the left. Now we shifted our left to the right by 1 hour and our right to the left by 1, and now we are at this point. So this is the container now that is formed, and so when we choose the minimum between 8 and 3, just like we did previously, and we multiply it by 3 minus 2, it gives us 3. And I'm sorry here, our maximum water will remain 24. Why? Because 24 is greater than 3. even though the amount of water this container can take is 3, but we have a much more greater container in the graph. So what we do now is that we are going to reduce our right by 1. Why? Because right is lesser than the height of the right pointer is lesser than the height of the left pointer. So right now we shifted our right pointer from index 3 to index 2. Now the left and the right pointer are pointing at the same item, and a single wall cannot make a container, so there won't be water, it will all pour away. So at this particular point now, what we are going to do is that we are going to break. Why? So that's the logic. Now alright, let's go into the code implementation. So we are going to be defining our function as largest container, and we are going to be collecting height, which is a list of integers, and the return of the function will be an integer as well, so which is actually the amount of water that the largest container can contain. So I love to write out my variables or parameters now. Let me see if I have it in the alright. Now we are going to be defining the maximum water. So these are initialization. Maximum water is the one that will be the maximum water that will be returned. So we initialize it as 0. So don't forget, from the logic also our left and right will be defined to be at the extreme, then of nums minus 1. So sorry, we are not dealing with nums now, we are dealing with heights. So now while left is less than, I hope and believe you understand what we mean by left being less than right. So because at the point whereby left become equals to right, there is no need, they are both pointing to the same vertical line. So and we are going to loop out, and even if left is now greater than right, there is no need to loop also, because the condition the loop have to continue while left is less than right. So and what we want to do is that let's calculate the amount of water. So let's call it amount. Don't forget our formula, the minimum between the height of the left and the height of the right. So we get that minimum and we multiply it by the right index minus left index, like we explained in the logic. So now our maximum water is going to become, in case, so it will be the maximum between the existing maximum water and this amount, because we are not just going for the amount, we are actually going for the amount if it is greater than the previous maximum water, so that we can return the maximum. So after doing this, now we are going to check if height of left, if it is less than the height of right, and if it is, what do? We increase our left by 1. We're also gonna check, so else if height of left, if it's greater this time around, so guess what we are going to be doing? We are going to be reducing our rights. So else, that is, if it is not greater than and it is not less than, definitely it will be equal to. So in that situation now, we want to increase our left and reduce our right, and at the end of the day we want to return maximum water. So and we are just gonna call our function now, and we are gonna call it on the height. So this is it. So let's run it and check out to see what is gonna be printed out. So 24 is printed out here very fast. So that's it, and that's the answer. So we're gonna be writing it in JavaScript code now. Right now we have the JavaScript code implementation, and you see the same logic, different language, same logic, different syntax. So it's just the same thing. We define our variable maximum water and our left and our right pointers, and we place this condition as well, that while left is less than right. So we define the amount and we try to check the maximum between the current maximum and the amount. So whichsoever is greater will be assigned to maximum water. And right, we come here and we try to check if the left pointer is pointing at a line that have a higher height than the right pointer. If it does, we increase a lesser height than the right pointer. If it does, we increase our left by 1. And otherwise, if the left pointer is pointing at a line that have a higher height than the right pointer, we decrease our right by 1. So, and in a situation whereby they actually have the same height, we increase our left by 1 and decrease our right by 1, and at the end of the day we return maximum water. So it's gonna run just fine and give us 24 here. So thanks for watching, and I hope you enjoyed the video. Don't forget to engage and share. It's very important for me, for my growth of my channel, and for you as well, to see your recruiter, to be able to get in touch with your hiring manager, employee of the company they are dreaming to work at. So you don't know where your content can go. You sharing it, you don't know who is watching you. So thank you, take care.